Hello, my name is Corey Applegate, mentor of Team 3244 in the Granite City GearHeads out of St. Cloud, Minnesota. Welcome to week 3 of building our 2020 robot chassis. In week 1, we sketched the profile of our chassis, extruded those profiles to make the tubing, and used a rigid group to group all the parts together. Week 2, we added the holes to represent the holes that come with the Versa tubing system from VexPro, along with some of the general holes that we'll use for our idle axles and our gearboxes. This week, we'll add the gussets that would hold our robot together in real life. To get started, I already added one of the Versa blocks to the lower left corner. We need this to show you a small collision that we have and show you why we have to modify our corner brackets. To begin, I'm going to go to our assets library. Picking Versa gussets. I'm going to find the 90-degree gusset and drag it into our project. I'm going to rotate this to better fit this front corner and bring it down here a little bit closer to where we're going to assemble it. This time we are not going to use the rigid group. We're going to actually apply a joint. In the joint command there are many different types of joints. There's the rigid, the revolute, the slider, cylindrical, pin slot, planer, and ball. There are many YouTube videos that go through each one of these in great detail. Today we're only going to look at the rigid. Rigid is already selected. I'm going to pick my first component. You can see that one component is grayed out because that component cannot be selected since it is grounded. All the other ones could potentially move. I am going to first select a point on the bracket. The first part that we select will be the part that moves towards the second one. When you see I mouse over to this lower plane, these X's up here, these are different coins that I can select as a joint node. Selecting this corner node on this planer to this bottom. Now, getting a view to the robot, you can see those same joint coins show up. Pick this circle here, top planer, center of the circle. Since we had the rigid command, a small animation shows you how that's going to work, and I can hit OK. Right away you can see why I brought this part in. You can see as we adjust this back and forth, we'll always have a collision with this bracket. So what we do is we cut these first two holes off. Right now this is linked to the asset library, so any changes we make to it will change the asset. We're going to break this link so we have our own component to work with. Activating this component, we are going to cut this end off. We're going to select Create Sketch. We're going to create a sketch on top of this part. I'm going to draw a construction line from the center of the third circle to the center of the second circle. I'm then going to draw a rectangle using normal geometry. I'm going to draw a rectangle just larger than the area that I want to cut. I'm going to apply a coincident constraint using the shift key, grabbing the center of our box and locking that to the center of this construction line. This will be all fine. We can use this box to define our cut. Finishing the sketch, we're going to grab the extrude, select this entire profile, and again either drag the arrow backwards to cut or come over here and select Operation Cut. You can see here as I drag down here, this is going to cut both the bracket and the tubing. We do not want it to cut the tubing, we can come down here and make sure of that by going to Objects to Cut and deselecting the drive rail, as well as picking the to object distance and grabbing the bottom of our bracket. Here I'm just going to go with this operation to finish the cut. With this bracket now cut, you can see when we go to the top view, as this bracket, this first block adjusts back and forth, no longer a collision. We are now going to copy this bracket and attach it to the rear. Since we are trying to create a dynamic chassis, I'm going to first simply copy this and attach it to this hole right here, but you'll see there's a problem, and I'll show you the solution. So first, by selecting the gusset that we have, using Control-C to copy, paste new, and I'll shift this bracket to the other side. I'm going to flip this bracket over 180 degrees to get it in the right orientation. I'm going to raise it just so I can see underneath it a little bit. Hit OK. I'm now going to go apply that same joint, selecting joint, capture position, select this first coin in this corner, select this last circle. You can see our rigid joint is now created. Okay. Now this looks fine, but what if we were to go and modify this chassis? Say we get to next year's design and we decide we don't want that 33-inch or 32-inch robot. We want a 31-inch long robot. You can see what happened is this bracket did not move because that was attached to a hole, but now if I hide that, is out here. That hole disappeared because we cut an inch off this chassis. So what we will need to do is use that parameter to adjust this bracket. Undoing these past few changes, deleting this rigid joint, what I'm going to do is hide our first gusset. I'm going to join this part to the same point that drives all these holes. The bracket's in the right orientation, but obviously in the wrong spot. What we can do is we can create a Y offset. You can see this Y offset go more and more negative as I move it closer to where it's supposed to be. So what we can use is that parameter we created last week, drivetrain length. We want to make sure that's negative to go in the negative direction. You see it put it way out here in the out here beyond the chassis. That's because our drivetrain also includes that length includes these two 1-inch 1x1s, plus they're a 1/2 inch in on each side. So 1.5 inches and 1.5 inches. If we want to drive that closer, we can add 3 inches to that part. Hit OK. I can turn on this bracket, and now no matter what we do, when we change these parameters, that bracket will adjust accordingly. Now with both corner brackets turned back on, we can now just use the mirror tool to mirror these to the other side and to the bottom in 2 steps. Since our chassis always grows and shrinks relative to the origin, that makes this possible. But I'm going to create mirror, select components if not already selected. You can either try to select the components on the model or come over to the tree and select the 2 components, which is sometimes easier. Select the mirror plane, selecting the YZ plane, and OK. You can see those parts are now there. Doing this again, create mirror, pattern type with components, select the 4 brackets, select the mirror plane, the XY plane, OK. You can now see that simple. We have our 8 corner brackets. Now, if we modify, change parameters, change the width of our robot to 25 inches maybe, and the length back to 33, since this is all tied to the origin, that mirror pattern always works, dragging those corner brackets to where they need to be. With most robot models that we build, we skip over the rivets and screws. Sometimes having all these individual parts in our models will degrade the performance of our computers. I'll return the chassis back to our starting size of 27.5 by 32 long. Now with the rails having a way to attach them permanently together, it is time to add the features to attach our bumper rails permanently to the chassis. To do this, I'm going to first activate the drive rail rear so we can modify that. I'm going to create a sketch on this plane here. To see things a bit better, I'm going to tip it down and zoom in a little tighter here. I need to drill a hole ½ inch down, and to keep everything symmetrical and lined up, I want to grab this top hole feature. To do that, I'm going to first add a point where I'm going to drill my hole roughly, and I can add a dimension from this top edge to this point at 0.5 inches. To find out where that hole is relative on this edge, I need to project that hole to this edge. I'm going to first hide the gusset so I can see the hole a little better. Create, project include, project. I'm going to project this hole. You can see here that a purple line has appeared on our sketch plane. I can now use the horizontal vertical constraint, holding shift, find the center of that projection, then selecting the point. You can see now that that point is fully constrained. I'm going to finish this sketch and now add a hole to this point. How we attach these bumper rails is we install a screw threaded in as a stud and then slide the bumper rail over there. I'll show you how. So we're going to add a hole at this point. We're going to use this counter bore hole to cut a large hole for access, as well as select tapped hole. The counter bore hole we use is a 3/4 inch. The screw is going to be a number 10, 32, and then we'll select OK. You can see this drilled a hole through both our rail and our bumper with threaded holes. That is fine. We'll use that feature from the other side later on. We now need to add a few more holes along the side of this rail to attach this. We're going to use the pattern. We're going to pattern feature by selecting the hole. We're going to select a direction, grabbing this edge of this rail. Spacing, 1 inch apart. We want 4 of them. We don't use all 4, but we like, since we're here, we like to add a few extra holes just in case we need them or if threads get stripped out. With these 4 holes, we're going to add 4 more to this other side. We don't have to draw them. We can use the mirror. Create, mirror, features, objects. We're going to grab first the original hole and the pattern. The mirror plane will be this YZ plane. Okay. Those 4 holes are now on the other side of our rail. If we go to the top level and spin around and view from the rear, you'll see these holes are all drilled all the way through. We are now going to add that similar hole pattern to this back side. So how we're going to do that is we're going to activate our bumper mount rear. We are going to draw a sketch on this backmost plane. We need all these features so we can project by going create, project include, project. I'm going to project this entire rear profile. Okay. Finish sketch. Going to create a hole. Selecting each one of these points since they're here. This side we do not want to be threaded. We want it to be clearance holes, so we'll select the simple hole. We use a number 7 drill bit for a clearance hole, which is 0.201. We want to make sure that we're only cutting the rear bumper mount and not the threads out of our rear rail. Like objects to cut and deselecting drive rail rear. Okay. Now activating our model, we can look straight in the back and we'll see we have our threaded drive rail and clearance hole for the bumper. We can now take a 1032 screw from the inside, stick it out, and use it in deep wall socket, add a nut on the inside of this rail. We are now going to repeat those same steps to the front, and I will fast forward through those. Okay, so you should now have the same as we had in the rear. A tapped hole in the drive rail with a clearance hole in the bumper mounting rail. That is all for this week. Well, let's turn these brackets back on so we can finish this and save our project. That concludes building the 2020 Granite City GearHeads chassis. Next week we will start a new assembly, importing these drive rails or this drivetrain into it, and adding the gearboxes and axles. Till then, good night. Take care.